Mhm. Okay. Okay, so welcome everyone. We are in week 9. So this week we are gonna cover chapter 5, as we mentioned before. So let's start to the today's chapter. So the chapter name is From Conceptual Design to Relational Implementation. So before starting this chapter, what we did on the chapter 4, we tried to develop a class diagram based on the object-oriented modeling, if you remember. And then we mentioned that there are two different methods. One method is for sure using the ERD, entity relationship diagram, but we mentioned that we are gonna work on the object-oriented modeling, which technically we are developing the class diagram out of it. And we just saw the difference between the class diagram and also the ERD. And we learned how to create those type of diagram. And as one of the assignments for you, chapter 4, you had to create those class diagram as well. And then, as we mentioned, we said those class diagram is so important because based on the relationship, based on the attributes that you're going to put in that specific diagram, you are going to create the database with SQL coding. And we mentioned that as much as you have more detailed information and more necessary information, for sure, not including unnecessary information, then the outcome, the report that you are going to receive later from the SQL coding, it will be more detailed, it will be more useful, and definitely have a better performance. But this week, we are doing exactly reverse of what we have learned in the last 2 weeks on chapter 4. Okay. So this week we are assuming in that stage that someone already gives that a specific class diagram to you, and now it's your time to create a database out of that one. So now you have to try to interpret that diagram, and it's not that much easy that we probably think about it. So it should be go through some specific stage, some specific process, and definitely add more details to it when you are trying to develop it. Sometimes it is possible that some other people create a diagram for you, and now you, as a data analyst person, as a data, not data analyst, I mean data based analyst person, now you are the one that you have to go and create data. If both teams are the same, for sure, it's gonna be easier work, but sometimes it's possible that the two different teams works on it. Okay, so in that case, now we are assuming that okay, some guys are giving us that specific diagram, that a specific class diagram, the one that we learned so far, and now it's time for us to translate it to the database schema and then creating a database with SQL. By database schema, we talked about it before. For example, when we have like a table or class, I don't know, whatever the student's name, a faculty, whatever name. So we learned that, for example, the database schema, it means we are writing the table name, for example, faculty, and we are writing for example, the first attribute, which is the faculty ID, as a primary key, and I don't know, first name, last name, as the rest of the attributes. So this is the database schema. And if we have foreign key, we would address here the foreign key in this table is, for example, something else. Okay. So now we are learning how we can write that database schema, and then how we can write a code on SQL to create those tables. Today, we are going more through the concepts. We will see a little about the coding, but we are not doing any coding today. Wednesday, we will go through the SQL coding for creating a table, change the table, update the table, removing the table, adding the table, something like that. So that's the job that we are gonna do it on Wednesday. By today, we are gonna go through the concepts of how we can translate, how we can transform that conceptual model into the relational data model that we have, into the database schema and also the SQL coding. So let me just minimize this one. So we learned so far about the class diagram. So the class diagram we mentioned, as much as you have more detailed class diagram, you will definitely have a better understanding of that business. So the best class diagram is for us is the best that can capture as much as information through that business. So if at this point someone is going to explain you their business, if they can share that data model, that class diagram to you, you spend a couple of minutes, hours, whatever, on that specific graph, on that specific class diagram, then you will have a better understanding of the business, how the business worked for them. So as an example, the one that for the red cat shoes, so we saw that, okay, when you go through this data diagram, data class diagram, you will see, okay, now this group, I don't know, make a purchase from the manufacturer create this, employee create this one. We have this type of employee, this type of customer, I don't know, wholesaler, I don't know, retailer, all the information technically are in that specific diagram. So that would be like a, again, class diagram that we have. And the same, we mentioned that we also have the ERD or entity relationship diagram. So that's type of diagram, the same, just with a different notation as we mentioned. So we, again, at this point, we would like to see how we can transform those diagrams into the SQL coding, into the real database. So if we do the transform correct, technically we are gonna meet the first normal form, second normal form, and third normal form. And then we can claim, hey, we are in the fourth normal form in this data set. And we know by fourth normal form, which means we again, we satisfied the first, second, and the third normal form. And also we don't have any uh, multi-value dependency for the fourth normal form. So technically, you can say the database I'm creating is the one that there is no data redundancy, there is no data inconsistency in the output. So that would be considered as a best version. But for doing this process, we have to learn some context. The first one, which we are going to learn it, so right now we're in the transforming level, is what we call it as a base class, or base set, or base entities, or base table. What does it mean by base table, or base set, or base entity? Depends on the object-oriented or the ERD, which means the table that technically is not derived from other things. It's originally itself. But what does it mean as an example? Imagine we had this person, entity, person class, person table, person set, whatever. And then we had this, for example, faculty as well. And we remember that this is the generalization, specialization relationship, the one that we also learned again last Wednesday, and review it again. Okay, right? So right now, between these two tables, technically the faculty table is derived from the person table, but the person table itself is like an original table. It's not derived from any other table. So that's why we call this one as a base table, base class, base set. Okay, so technically this one is not created based on another. Or if you remember, for the many-to-many relationship, we said this one would be a cardinal sin. So we said whenever we have the many-to-many relationship, we have to create an association table. Okay, so that association table technically originated from those two tables. So those two tables are the base table, are the base class. But this new one is not anymore because this one originated, created based on those two. Okay. So this base class, it matters a lot. So whenever we are trying to transform a relational model, a class diagram, we have to start and working on the base table, base sets, base entity. So for this one, as we mentioned again, they are not derived from another class. And we already shared it, I think. Yeah. And also, as we mentioned, as an example that we had, for example, for the many-to-many, they are created, the association class. So those one considered as one of the other example as well. So the first one, we have to make a name for it. For example, right now, in that specific class diagram, we are just having a small example. We have this one, a sales table or sale entity, which has the product name and amount. Okay. The point is, we remember that we technically don't put foreign key in the class diagram because of the extra information. Sometimes it is also possible that people also remove the primary key as well. Okay, sometimes it's possible. So in that case, you need to define a primary key for this table when you are developing a database, when you are creating a database schema. So in this specific example, the sale table, we are just naming it as a sale. It makes sense. So for the database schema, we are just mentioning, okay, this is the sale table. So out of product name and amount, any of those could be considered as a primary key, right? Or can we have any of those as a primary key? No, product name is not unique, and also amount is not unique. So in that case, we can see, okay, in this specific diagram, and let me clear one thing for you. At this point, we are not here to make the class diagram correct. They gave us the class diagram. There might be some issue with it. It doesn't matter to us at this point. What we are trying to learn is to transform that current, whatever table we have, to the database schema. So in this one, there is no primary key. So we have to assign primary key for it. So I, as a database creator, I would say, okay, this is the sale table. I would name it as a sale. Why not? Why should I change it to something else? Sale is okay. Product name, amount is the attributes. Let's have it. I like it, but there is no primary key on it. So for the primary key, sale ID. You see, that's why I just added the sale ID as the primary key and the rest of the attributes. So right now, I just transformed that specific table in the class diagram to the database schema version. We are going again step by step, try to learn this transforming process. Now, imagine, for example, we have those type of generalization specialization. So I'm not going to ask again, what does it mean by generalization and specialization? Because last Wednesday, we spent a lot of time to try to again find what's the generalization and specialization. So in this type of relationship, the one that we have the person as a generalization group or as a super group, and married person as a specialization group or as a subgroup. Okay. In this type, we will first know about the inheritance rule. We know that whatever attributes the generalization group have, the specialization, they will inherit those attributes as well. Okay, without any doubt. And also whatever relationship they have, this one inherit those. So we will start with the base class. Between these two, which one is the base table, base entity? Person, because we said that the base one is not the one that derived from other one. But here, the married person is the one that technically created out of the person. So this one is not the base class. Person is the base one. So for the person, social security number, name, address, and also the person. I would name it as a person. Why not? Why should I change it? So I would name it as a person in the database scheme. So which one is good for being like a primary key? SSN, name, address. SSN is the good one to be as a primary key. But if you remember, we mentioned that about like an abstract class, whenever we said we cannot print that specific context, it's better to have another ID for it. So here, person, we cannot print it. Okay, so you cannot print the person. You cannot write it. Okay, so in that case, it's always better to have one surrogate key, the one that we mentioned that we are creating it. So here it's better to have the person ID. But yes, you're right. Social security number could be also considered as an external primary key. We mentioned that external primary key, which means they have a real world example. As I said, there is a real world example. But for us, in order to be more consistent with the other table, it's better to have the person ID as well. So person ID is the one, and the rest of the information, the SSN name and the address. Okay. Now let's go to the subclass, to the specialization group. Now I would like to create a database schema for this one as well. So for the married person, how many attributes we have for the married person? We have social security number, we have name, we have address, and we have a spouse name. So one way to name it is married person is a person. Am I right? So person ID as a primary key for it, and then social security number, name, address, spouse name. Okay, but as you see, there are some extra information. One of the things that we need to always pay attention when we are creating a database is to not create a room for entering extra repetitive data. We need to always make sure, think big, think in a company that they have billions of rows of data yearly, monthly. So in those, just one very simple, small changes matters a lot. So in that case, I have the person table, okay? So for the married person, I would definitely consider just these two, the person ID and the spouse name. So technically, this person ID is the foreign key that will refer to the person table, and also the spouse name is the only one that we need to have it. So it's avoid redundancy. So it's better to have one. There is also another one that we can consider, which we don't have it here. What if we just have the person table with person ID, social security number, name, address, and at the end, spouse name. If that person is married, we will have the information for the spouse name. If that person is not married, we are gonna just leave as a empty. So technically, there is a possibility for this database to just have one specific table for a person, not even two. But if we have two with this second version, which is fine, it's okay. But as I mentioned, we can just have this spouse name here and just have only one table that technically represent this relationship. Do you agree that this specific one represent the relationship? So if we have this spouse name here and creating just this table, technically we are creating a database that represent this generalization and specialization group, right? So nothing fancy. So that would be also when we are seeing the generalization and specialization group, how we need to deal with them when we are transforming them to the database schema and then creating a database out of this database schema. So now let's see what we can do if we have one-to-one relationship. So one of you read this relationship for me. Read this graph for me. Yes.
So one customer can have 0 or 1.
Exactly. Can have 0 at least or maximum 1 and
One customer can have 0 or 1.
7 accounts. And what about the other side? So each checking account can be assigned to one and only one customer, and saving account assigned to one and only one customer. And this is just example. We know that for the reality, each customer can have many, and each account can be assigned to many customers as well. But in this specific example, this is the one-to-one relationship. Okay. So in this one, what we need to do in order to database schema. We are starting with from the class base. Again, customer is the class base, checking and saving both are the class base. So customer, the customer name is the good name for it, and the customer ID is the primary key for it. I will consider primary key. Unfortunately, we'll have others, but let's just keep it simple at this point. Checking accounts, saving accounts. For the checking account, we need to have the primary key. The primary key, I would say, checking account ID. For the saving account, I would say saving account ID. Agree? Then we need to address this relationship. How we can address this relationship? With adding foreign key. The foreign key that technically they didn't wrote it and they didn't mention it in the class diagram. So what is a foreign key? Foreign key is the primary key of the customer table. So technically we put customer ID here as a both foreign key in these two tables that technically customer ID references the customer table and also here the same. So that's also another way when we are dealing with this type of one-to-one relationship. This one-to-many relationship. So customer can have at least 0 checking accounts or many checking accounts. Checking account can be assigned to exactly one and only one customer. So this is the one-to-many relationship. Is this the cardinal sin? No. There is a rule for it. Let's memorize it. Insert the primary key of the one side as the foreign key of the many side. So which side is one, which side is many in this one? Which side is one, which side is many? Customer is the one, checking account is the many side. So rule for it, insert the primary key of the one side. One side primary key is customer ID as the foreign key of the many side. So right now for this table, we write the customer ID with whatever attributes that we have. Checking account, which is on the many side, we'll say checking account ID, comma, customer ID, which customer ID is the references customer table. So technically, again, one more time, insert the primary key of the one side as the foreign key in the many side. So that's the way that we can transform it, translate it to the database schema. Okay? Now, any question for this one? Clear? Now for the many-to-many. We mentioned that many-to-many is cardinal sin. When we have the many-to-many, we have to break it down to the association table. We have to break it down to the one-to-many relationship. Okay? Again, right now, here, we are not here to correct the data to the class diagram. They gave us this class diagram. We know for sure that there is a issue with it because it says customer can have 0 or many checking accounts, and checking account can have at least one or many. So there is a many-to-many relationship. We know that this is wrong. They should have created association table in this one. They didn't. We don't care. We, as a database analyst, at this point, we have to create it by ourselves when we are creating a table. That table here, we call it intersection table, just the name. Over there in the graph, we name it association table. Here, when we are creating a database schema, we are naming it as an intersection table. So what does it mean? customer checking account. We see that the customer has the customer ID as a primary key. Makes sense? Checking account has the checking account as a primary key. Primary key makes sense. But we know that we should have another table. In the class diagram, we name it association table, association set, association class. Here we name it as an intersection table. Let's name it something, whatever. It should make sense. Here we are just naming as a has checking account. So right now in this specific example, we have the customer table, which customer ID is a primary key, whatever attributes, and then checking account, which is the checking ID, checking account ID, whatever, as the also primary key. But the point is, we have to have the intersection table because they didn't create the association table. So in this one, we are naming it as a has checking account, whatever you can name it. It should just make sense for you when you are creating it. So the rule for this one is you need to put the primary key of the two sides as a key here, as a like a foreign key here. So technically, from the first one is customer ID. From the second one is checking account ID. So right now, we will have a new table, the intersection table, which we are naming it has checking account. And the attributes for it is customer ID and checking account ID. And right now we know that these two together create a what type of primary key? Composite primary key. Because each individually cannot represent the table, but together they can be a representative of the table. So they are together as a composite key, and each for sure is the foreign key that address one of these table. Okay? So one more time. In this specific one, we knew that there is an issue. They had to create the association table. They didn't, we don't care. We have to create it for ourselves. What we are naming it, intersection table. The intersection table, we are naming it something. The key for that one, the attribute for that one is the primary key of the two tables that we had. And together they are composite key, but each considered as a foreign key. Okay, make sense? Right? The challenging time is when you have the full table. Yes,
So you said the customer can checking account be
0 to many. So there is a many-to-many relationship, which we said that before, this is the cardinal sin. Technically, we shouldn't have many-to-many relationship, never, into the class diagram. So those people that created this, they had to create the association table. They didn't. It doesn't matter. We are creating right now when we are writing the database schema. We are creating a new table. This new table, we are naming it intersection table. Make sense? Yes. This table that we are just,
said like this.
it just name it has checking account. You can name it whatever you want.
So that is not making customer.
It's gonna be, the attributes for it is gonna be the primary key of these two tables. The customer table, what is the primary key for customer table? And what is the primary key for checking account table? ID. So these two will be the new attributes of that intersection table. And together, they are the composite key. Each of them itself cannot represent the table, but together, joined, they are representative of the table. Okay? So Now, in this specific example, they did a good job. They created the association table. Okay, they made the job easier for us. So similar to the previous one, except whatever attributes they had it here, we are going to consider it. So very quick. There is a many-to-many, yes, but there is an association table. So they fixed that issue, that problem. So in that case, again, for the student, name is not enough for the as like a primary key, right? So we are naming it student ID and the name. For the course, title is not enough to be a primary key. So we are writing course ID as a primary key and the course number, course name, whatever. And then the enrollment table, which is right now association table, we have the same rule. We need to consider the primary key of these two tables as attributes plus whatever they added here. So technically a student ID from the student table course ID from the course table and grade, which is already here. They put it here. So technically these are gonna be the database schema for the enrollment table, which is the association table. Okay? So foreign key is student ID references the student table. Foreign key course ID references the course table. Right? So the only difference with the previous one, the table wasn't existed. We created, and for the attribute, we just used the primary key of each table. In this one, they created the table and they added grade as one of the attributes. So we should consider it. So again, attributes are those two from the table as a primary key, plus whatever we had, which is the grade table. Nice. So recursive relationship or recursive relationship, what was it? You all know it. We at least mention it 3 times in class. The table has a relationship with itself. Example, the employee table. We mentioned that. I work in this department as a faculty. I am reporting to the department chair. The department chair is also an employee in this school. The department chair is reported to the dean. Dean is also an employee in this specific organization. So we are all in one entity. We are all in one set, one class, but we are reporting to each other. So how we can show it into the database schema? How we can show it? That this specific database schema report to itself. Let me ask from another way. Whenever you are saying some table, refer another table. What do you use in those tables to referring each other? Foreign key. Yes. So right now, we just have one table. So technically, we should have another key here, which would be considered as a foreign key of itself. Okay? In this specific example, we would say, okay, we have employee table, let's have employee table. First name is not a good one to be as like a primary key. What is good be to be a primary key? Employee ID. Let's have an employee ID as a primary key. I, Hossein, primary key is employee ID 112972, blah, blah, blah. First name, last name, phone, hire date. My advisor, he is also not my advisor. I'm not PhD student anymore. My department chair, Dr. Zafar, he has the employee ID, right? He has the employee ID, but the point is we can add new column to this one, like a supervisor ID. Technically, this Dr. Zafar supervisor ID is the same as the employee ID, okay? But we are here just trying to show this specific employee report to this specific supervisor. Example here. Let's forget this example. For this one, the table we have here, let's say 3 persons are here. The dean, Robin Shrami, the chair, Humayun Zafar, me, Hossein Moed as an employee. Okay, each of us, we have the employee ID. He is the employee ID. She is the employee ID 1. My chair is employee 2. I am employee ID 3. Okay, so right now there is another column here, supervisor ID. Okay, who I am reporting. I am reporting to Humayun Zafar. So the supervisor ID for me is 2. Who Humayun report to? The dean, the number 1. Okay, and who's Robin Shurami report to? Let's assume she's the top. Let's show she's not reporting to the president. She's the top in this specific business. So for her, it's gonna be just a 0. No value. So technically, right now we can see that this supervisor ID here could be considered as a foreign key because it shows I am reporting to this person reporting to the chair, to the dean, and also whatever hierarchy that this system has. The example here, we have this one exactly. So right now, the H1 recover. So technically, the employee ID is 1520, and the supervisor is 3231. So right now, this person will Jared reports to 1520, which is the H1 recover. So that's the type of way that we can address this one. So we are just by adding the supervisor ID, technically we are reporting to the different person in our organization. So that's the way that we can also show the recursive relationship. Now it's time for us to creating a table. Okay, so in chapter 2, assignment 2.3, 2.5, 2.3, 2.4, 2.5, we were supposed to create a table, if you remember that. And we mentioned that in order that you first have to run this create table function into the assignments. And whenever you create it for the first time, you gave error, you received error because you didn't have that table before, okay? Because there was a function for it, for example, drop table, and we mentioned that there is a drop table if exists. Today, again, Wednesday, we are going to go through the codings more. Today, we are just reviewing it. So for defining the table, again, the name is the table name that we have here, and each column, we know it could be an attribute, and they have their own constraint. You will see the value type. For example, employee ID is always a number for us. We have to mention, hey, this is a number. First name, last name, it's like a character. So it's not number in the name. Do we have any number in the name except the Elon Musk? Maybe, I mean, we don't have any number in the name. So that's a character that we can have, we can consider it. Or for example, if I am having a column that I'm calling the states in the United States. So just I need to have 2 characters for it in order to show it. So this is important. I need to exactly mention. If I know that I don't need more character, I need to exactly mention how many character I need. Because the point is I need to save storage in this database. Again, in a database with the billions rows of data, monthly, yearly, even 1 byte matters. Okay, so in that case, we have the create table function. We will go through the coding again on Wednesday more, but let's see this example. So the first line, drop table if exists customer, we know what it is. What does it mean? It means if we have customer table, let's first drop it and then let's create it. If there is no customer, so this one is not gonna work. For the assignment chapter 2, why we got error? Because we had drop table customer, we didn't have if exist. So it assumed that you have the customer table, then drop it. But since you didn't have the customer at the very first step, that's why you received error first. Then the rest of the code is gonna execute it. And again, the second time when you run it, you wouldn't receive error because you created a table, the customer table. But with this line, we are kind of ignoring that part. If the table is there, it's gonna delete it. If it's not there, nothing happened. Okay? So create table. So maybe it's good to have it. It's make more sense. So I'm not gonna create anything, but let's have it on my okay. So in this one, let's try to understand the code. Create a table is a function for it. What's the table name? Customer name is the table name, customer. Now we have to define each column, each attributes. The first attribute is customer ID. The customer ID, I would like to have it as an integer. This is the number. And the customer ID is not null. It shouldn't be null. It means if I don't insert anything to it, I'm gonna receive error. Okay? So technically this one should have value because this is primary key. Later we'll learn that we need to write here as a primary key, we'll see. First name, character 30. What does it mean? What do you think? Yeah, so it's a character. That's a type of the attribute. And the length of that character is fixed 30 character. If by chance you have a name that have over 30 character, you cannot put it there. Okay? Last name, the same. Now, street address is VAR character or variable character 50. What does this mean? What does this mean? What does it mean? Variable character.
Also, on numbers.
No. The first one, you, regardless of the whatever data is gonna be, you are reserving 30 characters as a first name. Okay, you are reserving it to your system. My name, HOSSEIN. 1, 2, 3, 4, 5, 6, 7. Technically, I am burning 24 characters in that data sets. Yes.
Oh, the numbers there, that's what you're talking about?
Yes. Character 30, which means 30 characters. So right now, I just burned 24 characters in the data sets. I just occupied some storage in the data set, which I didn't use it. That's the waste of storage. Again, in a real big data set, it matters a lot. But when I am saying variable character, it means if I write Hossein, Hossein, it will check it first. How many character it has? 6, right? Hey, 6, right? So let's just reserve 6, not more. Okay? So this is maybe better, but maybe also not better always. Because you might at this point say, why not always using variable character? So why do you think it's not a good idea to always use the variable character? What do you think? If I use the variable character, we just learned that we are not gonna wasting any storage in the data sets. We are exactly reserving whatever we are needing, whatever we need, right? But why? Yes.
Didn't you say variable character?
So variable character, it's gonna go through my name and check it. Hossein, just pay attention. Check it. This check matters. 1, 2, 3, 4, 5, 6. Hossein has 6 character. Let's reserve 6 character for Hossein, not more. Okay? So technically, we are not wasting storage for more reserved character. But why we don't always use variable character? It makes sense that we should always use variable character.
Wait, so name is more than 30, but it's not.
If we are on the character 30, in that case, yes, we are gonna have error. But again, if we are also a variable character and if it goes over 50, we are still receiving error. That one is also have a cap. But right now, the difference between these two is for those that, for example, have 6 characters, and for this one, it's just assign 6 one and not waste anymore. It's about the processing time. It's about the CPU. So the system, it goes character by character and check it. It may take 0.0000002 seconds, but for the real big data sets, even this one matters. That's why it is up to the database person that are creating to decide which one I should go. So is it clear why we need to make a decision between these two? So when we are using a variable character, the system spends CPU, spends some time to process. Okay, this one has 1, 4, 5, 6. 6 is enough. Let's cut it. But that one, without anything, we have 30 characters, so let's put it there. Let's go to the next one. So that's a trade-off between like the storage and also the CPU time. Okay. And for estate, we know always 2 is enough for us. So let's just always keep it to the 2. Postal code, 6, 5 is enough. Let's have 6. The country, whatever, the phone, whatever. So here we are saying that the primary key is customer ID. Okay. Again, we will go through the coding on Wednesday. So couple of points that we need to know. Again, the data type defines the characteristic of the data stored in that column. Is it number? We need to go with the number formats, integer, all the things we will see. If it's character, we should have the character. If we want to have those primary key that generating automatically, that's the function for it. The auto increment function, we will learn it later. Not null, again, prohibits a new record with a null value for that column. If you are saying this is the not null, the database administrator, the person that entering data, they should definitely enter data. Otherwise, they're going to receive error. Unique coding is prohibited in your record with duplicate value for this column. So we can also add the primary key, as I mentioned, and we have the check table as well. For example, you are creating some value and you would like to always have it over 0, over 10, over 20. So you can add a check. We will learn more about this later. But this is different type of formats. If the number is a very like a big number, we need to change that type, the int, the integer, to the big integer version, which technically have the 8 bytes storage. Integer, small integer, tiny integer, bit. So you see, between the tiny integer and small integer, the difference is 1 byte. Okay? To us, it's nothing. But again, in a database with a billion rows of data, even 1 byte matters. That's why there is always room to make the database more efficient and more better. The decimal, for example, you can have the numbers with the 2 decimal point. We will learn it. We will write it like a 8.2, comma 2. So 2 decimal point out of 8 characters. If it's money, we can just put it money as a format. Small money, the same. And here we have another one, character. Again, where n as a defined number of character. The variable character, n character, where is n defined as a number of character, which n is between 1 and 4,000. So that's also another one, n variable character. That's a different formatting. So more formatting is in the book. Make sure to check the book. And also for the date, that's a type of different formatting that we can have for the date as well. So this is the first one that we saw it already. So another one. We are creating a table. Okay. We are creating a table. What's the table name here, guys? Cell table. So cell ID is the primary key, right? The integer not null. It should be not null. Sale date, the format is date. We know that the date format is this one. Y, MNDD. So it will automatically consider this version. The tax is the numeric, but 8 character with 2 decimal points. Shipping, again, it's a numeric, 8 character with 2 decimal points. Customer ID is integer. Primary key is sale ID. Foreign key is customer ID, which references customer table on delete set null. This one, the delete set null, different type of null that we have when we are referring. We will talk about it on Wednesday. When we are writing about the foreign key, we need to mention this is a different, like a set null or restrict or cascade or set default. We will talk about the difference between these later. But at this point, we need to mention that this foreign key, which is the customer ID, references which table, customer table, on this specific condition. We will learn about it. So for a primary key, there are 2 ways to define it. One, to just simply say customer ID, integer not null, and at the end, mention that primary key is customer ID, or just customer ID, integer not null, primary key. So you can just name it whatever you would like. Add it just primary key here at the first line, or have it more like an organized version at the end and just mention primary key is the customer ID. So for the foreign key, as I mentioned, we will learn more, and also the drop and alter the table also the same. So these two, let's stop here and work on it on Wednesday, plus the coding that we are gonna work on the next meeting. So let me just stop the recording. Okay, so welcome everyone to week 9, chapter 2. Okay, so we are exactly recording. Nice. So I'm just gonna do a quick review after what we discussed on Monday, and then continue working on it today lecture. So we were in that stage that, okay, at this point right now in chapter 5, we have the class diagram, the one that the people created before. We don't know if it's created in a right way, wrong way. We don't care at this point. We just want to know when we have those type of diagram, how we can translate those, how we can transfer those to the SQL coding. That's what we did on Monday. So we started with a class diagram that we know all what is class diagram. So technically, the diagram that gives us all the related information, necessary information for the organization that we are going to work with. And then we talked about the base class, base sets or base entity. We said that, okay, when you going to transfer those graphs to the coding, now it's time for you to go through the entity by entity, class by class, set by set, and see how you can have it as a database schema. Database schema, which means, for example, table name, parentheses, all the attributes, all the things that we got. For example, in this one, we said the base class is the one that's technically, it's alone, it's individually alone. So it's not derived from other tables, other sets. So here the sale is the one that we are naming as a sale. Hey, but sale ID is the one that we can consider as a primary key. We mentioned that we always don't have foreign key, and sometimes they also don't put primary key as well. So if you don't see the primary key in this one, you need to find the primary key. You need to create some. For this one, I would say like a sale. I would name it as a sale ID, and then write a database schema like the one that we have here. And then we went through the transforming classes. The transforming classes, I mean that the process that we're doing, we went through the generalization and specialization group. We said, okay, right now this specialization group, it's derived from the main group, which is the person, as a generalization group. So for this one, we start with the base one. Base one here is the person. Person, we try to have the person ID as a primary key here and the rest of the attributes. The same, we are going through the subclass, the specialization. For this one, we said we have two approach. The first one, having one extra database schema for this one, and just include the primary key, which is the person ID, and just the only attributes we have here, which is the spouse name. We are not going to repeat it again, all the one that we have as a generalization group, because it's extra. We also said sometimes you can just make it this one also easier, just to this person as a generalization one, adding the spouse name here as another attribute. If the person has a spouse, let's have it here. If no, non-value. So technically, we can also have this one in this version. And then we talked about the how we can go through the relationship. So in this one, we have the one-to-one relationship. For the one-to-one relationship, we start with the base ones, which is the customer here. Customer ID is the one, and the checking account and saving account. Each of them needs to have the primary key. What is the primary key? For the checking account is checking account ID. For the saving account is saving account ID. We are just, for those of you that was not in the previous session, we are just reviewing very quick. And we need to have the foreign key. As you see, we don't have foreign key here, but based on the relationship, we can understand, hey, this is a relationship between these two. How we can connect two tables together through the foreign key. What is the foreign key? Customer ID. Here is the foreign key that we need to put it here. And then we went to the one-to-many relationship. There is a rule for one-to-many relationship. What is the rule? Insert the primary key of the one side as the foreign key on the many side. Here, the one side is customer, the many side is checking account. For the customer, we just have customer ID. For the checking account, insert the primary key of the one side, which is the customer ID, as the foreign key in the many side. So technically, checking account and the customer ID. And for the many-to-many relationship, we said that many-to-many relationship, when you have it in the database schema, is what is it? When we have the many-to-many relationship, it's a cardinal sin. We have to have the association table for it. Again, we are not here to correct this one. They gave this one to us, and they didn't consider association table. That's their fault, not us. So in that case, we are going to create some table for ourselves. The table, we name it intersection table. Intersection table is the association table, the same, just a different name. And then there is a rule for it. For that intersection table, the primary keys, which is going to be a composite key, is going to be the primary key of each of these classes. So technically customer ID, checking account ID. And if they did a good job and created the association table, exactly everything is the same as before, except we have to also consider the new attribute as well. What is the new attribute? Grade. So student ID, course ID, grade. And we talked about the recursive relationship, how the entity can have a relationship with itself, which was the employee table as an example. And we mentioned that you need to have one extra attribute here, which we call as a foreign key. And this one technically address that recursive relationship. And we mentioned about the defining tables, how we can create a table by create table function. Today, we are going to go through the coding for it. So we mentioned that you can start always by drop table if exists. We had it on the end of the chapter 2 as an assignment. So we can have the create table function, customer, and then start, go through the attributes by attributes, okay? And then you can define what are the type of attributes. Is it integer? Is it character? If it is a character, how many characters we should assign to it, 30, 50? Is it fixed character, variable character, all the things that we discussed on Monday. So also the data format, whatever format we can have. Again, if you were not in class, just make sure to go to the video that I'm going to post it after class, and also the book. So we were almost in this stage that we said, okay, for the primary key, we have to mention it in the create table function. There is two ways for it. There are two ways for it. The first one, for example, customer ID in the customer table is going to be a primary key. We can have it at the end of the section, which mention primary key is customer ID, or at the first customer ID integer not null, and also mention this is the primary key. We will see in the coding as well. But before going to the book, we need to learn something very, very, very important. We mentioned that when you want to connect two tables together, what is the only way to connect two tables? Using foreign key, okay? Right, the join is for the SQL coding. So you need to have the join function in the SQL coding, you're right. But you need to go through the foreign key, okay? So technically, for example, if we have table sale, and if we have customer table, okay? For the sale, we have its sale ID, some extra information. Customer, we have customer ID. So when I sell something to some people, I want to know which people, which customers. So in that case, I need to have customer ID here. So far, nothing new. Okay. So technically, we are referring to the sale table. Sorry, we are referring to the customer table through the customer ID. Okay, so which means whenever I am going to create a sale table, okay, I have to mention that the foreign key is customer ID, which references the customer table. So far, right? Nothing new. So here, at the end of the sale table, I'm just saying, okay, foreign key, this is a code for it. We will again go through it more through the book. The foreign key is customer ID, right? In the sale table, the customer is customer ID, okay? So customer ID references customer table, okay? Through the customer ID. Delete something, delete something. That's the important part that we need to make sure to always choose the right one. This is a little different things that so far we have learned. Just stay with me for a couple of minutes. So this is the function: foreign key, customer ID, references, customer table, undelete set null, undelete restrict, undelete cascade, undelete set default. We have 4 options for this one, but what does it mean by each? Okay, let's go for it. The first one, let me have this table. So sale ID, customer ID, and customer ID, first name, last name. Customer ID 1, let's create it vertically. So customer ID, first name, last name. The same here. Sale ID, customer ID. This is the sale table. This is the customer table. Customer ID 1 is Hossein Mohit. Customer ID 2, what is your initial? What is your initial? Your initial. Your initial. Hossein Mohit, what is your initial?
T.
I? T?
T.
T, okay. Yours?
E.
AD? ED?
E.
AB? Okay. So we have 3 customers, HM, IT, AB. Okay. So sale ID 1, who purchased it? IT. Sale ID 2, who purchased it? Hossein Mohit, customer divide. Sale ID 3, who purchased it? Again, IT. Sale ID 4, who purchased it? Customer ID 3A. So that's the table that we have so far, okay? When we are creating this table, we have to refer to this table, okay? When we set foreign key is the customer ID references customer on delete set null. What does it mean? It means that if for whatever reason, mistake, intentionally, whatever, we delete this customer, for example, customer 2, I2, if we delete it from this table, technically this one should reflect on this one. Do you all agree? It should reflect. So when we are saying that delete set null, what's gonna happen? Stay with me. It's gonna, now for what by mistake, we just deleted this customer ID 2. Here, there are also other information as well, right? Here, just we are gonna miss these 2 and we are gonna have it as a null. But the rest of the information will stay the same. Okay, so which means right now in the sale table, we have some sale that we don't know to whom we sold it, but we have the information. So just the customer ID, sorry, I just thought this is customer ID. So we have the sale ID 2 that right now we don't know to whom we sold it. But we have all the information. Is it the sneakers? I don't know, whatever we have. That's the set node. So in that case, again, one more time, let's read it. If the customer is deleted, any sales for that customer will be updated to reflect node just for the customer ID, just for that foreign key. We are just gonna miss this one here, and we are gonna have it null, but the rest of the information is here. Okay, but we don't know to whom we sold it. So if I create a table with that set null by mistake, if it is something missed from the customer table, in the parent table, which is this one, technically we don't know to whom we sold it. So we are gonna have it as a null. Okay, so that's the set null. We will review it again. And 2IT. If we say restrict, if we say, okay, on delete restrict, we can just guess what does it mean by restrict. Technically, if there is something related to the customer ID2 in the sale table, it doesn't let us to delete this information. If by mistake, for whatever reason, you try to delete it or you just make a mistake, you wanted to delete it, it doesn't let you, it gives you error, which is a good one, right? Because you have some information here that is related to the customer ID2, and it doesn't let you. So technically, deletion of the customer not allowed if the sale for that customer existed. So right now, in the sale table, we have, for example, sale ID2, which is related to the customer ID2. So if I want to delete in this one for whatever reason, it doesn't let me because there is a here. But if I have customer ID 4, which is the XY, if I want to delete it, does it let me or it doesn't let me? Does it let me? Customer ID 4. Do we have any information for customer ID 4 in this table, in the sale table? Where? This is the sale ID, this is customer ID. So you made my mistake, you want to type it here. So 2213. There is no sale information for customer ID 4, right? So technically, it led us to delete it because there is no associated value in the sale table. But if I had sale ID 5 for customer ID 4, it doesn't let me to do it, right? So the third one, foreign key customer ID references customer on cascade. What does it mean by cascade? It means if by mistake, intentionally, unintentionally, you delete some information, some customer from this table, it's gonna delete all related information for that customer in the sale table. So, for example, customer ID 2, that's related to the sale ID 1. For example, the number of items is 100, for example. Okay? If by mistake, intentionally or unintentionally, whatever, I delete this one, all the information related to the customer too is gonna be deleted. Wherever we have two, it's gonna be deleted. The first one, the set null, just put the null for the customer ID, but keep the rest. This one, it's gonna destroy it from scratch. I mean, it's gonna delete everything. Okay. The last one, set default, is exactly same as the set null. Just differences, instead of having null, you can, for example, put some keyword unknown. I don't know, whatever. Just instead of putting null, it's gonna add whatever custom keyword for it. This is so important. Let's do it one more time. say like 1, say like 2, customer 2, customer 3. Customer ID 2, I. Whenever we are referring to a table, we have to use the reference, the foreign key for referencing. So the code for it is foreign key. What is the foreign key? Customer ID references which table? Customer table on one of these 4 conditions: set null, restrict, cascade, set default. You tell me. Yes. Depends on the job that you are doing. To be honest, depends on the task you are doing. Sometimes, again, depends on the policy. I myself, if I have to create a database, I would always go with which one? If you say, what do you think I would always go with which one? Restrict. I always go because that's more conservative. If there is a report for it, let's keep it. If it's not, delete it. Okay? So to me, is that one the best one? Again, it depends on the policy of the company, because sometimes they would say, okay, it doesn't matter who we sold it, we just want to keep the information. At the end of the day, we mentioned that in a real big data sets, even one changes matter, one small change matter. So maybe they would prefer to not have the customer ID by choosing the set node and just having a node. So it's going to save time, save energy, save whatever, save storage in their database. But to me, restrict is the most meaningful. Again, that's me. I would prefer to not miss data. But if you tell me, if we go with the ones, the set node, so if by mistake I delete customer ID 380, what's going to happen in this table? This is the customer ID. That's it. Just this is going to be null. This is going to be null. Nothing is going to change. Okay? Nothing. So this is the set node. Nice. 3, 2. Okay. If we say with the restrict, if I want to remove the first one, customer ID 1, what would happen? Because, yeah, because there is a one row associated with this one, so technically it doesn't let us. If I want to go and delete the number 4, what's going to happen? Because there is no sale associated with customer ID 4. Okay, nice. Cascade. If I by mistake delete number 3, what's going to happen? It's going to delete the entire rows that related to the customer ID 3. And the last one, set default, same as the set null. Instead of null, for example, you can say unknown. That's it. Yeah, whatever. We also have 2 other functions that we already know: drop, create, we know it, and then alter. Alter is going to change the database. Kinds of like update. Yes. You have to see. It's going to tell you if you're supposed to do it. So, the first one, what does it going to say? What is going to say to you? Read it. So what does it mean? What we are doing by this function? Changing, you mean we are adding something to it, right? We are adding one attributes to it. The attribute name is cell phone, which is the variable character, 255 number of characters. Or, for example, maybe we are dropping something from the table. Alter table employee drop cell phone. We are dropping the cell phone out of it. or alter drop customer add primary key. Primary key, we're gonna adding some primary key to the table. Okay. Let's go to the book. Chapter 5, the schema and table definition. So here, what exactly discussed, all of the syntax are here. So we are gonna go through some of them, okay? And the rest, again, when you go home later, whenever you wanna study, just make sure to go through each box and try to run it, okay? So we are starting by creating 3 tables: customer table, sale table, sale item table, right? So technically, the customer table, we have the customer ID and the rest of the information. That's a primary key for us. In the sale table, what is the foreign key? Customer ID, which refer us to the customer table. And the sale item has two foreign key, which is the sale ID and the product ID and item set that refer us to this sale table. Okay? In sale table. So that's 3 tables that we are creating it. Okay? No question for it. Is it clear? No? We are going to create 3 tables. 1 table, sale table, customer table, 1 table, sale table, 1 table, sale item. Nothing new. Okay? We are just creating some tables. So for this one, this is the function that you need to go through. So you have it. So how this one works, tell me. How this one works? Okay, if we have the sale item, it's gonna drop it. If you have the sale table, it's gonna drop it. If you have the customer table, it's gonna drop it. Okay, so right now, run it on your side and tell me, do you get any error or no error? Did you get any error on your side?
No.
No error. And you were not supposed to get error, because the point is, if even you had the sale item or sale or customer table, there is a function here, drop table, if exists. It's not just a drop table, okay? If this one was just a drop table, you would get error, because, for example, sale item was not existed before, so you would get error, okay? So, do you think, critical thinking question, do you think the order matter here in order to dropping table? It matters, otherwise I wouldn't ask. But why matters? Let's have table, I mean, graph for this one. The first one is the customer table, which is the customer ID, the rest, right? The second one is sale table. So sale table is sale ID, some information, and customer ID. So these 2 tables are related, right? Right, because of the customer. And then sale item. Sale item. Sale ID, product ID, item size, quantity, sale price. So technically, there are a couple of foreign key on this one. Sale ID references to the sale table, and also product ID and item size, which refer us to the other table, inventory table, something. Okay, let's imagine we have the product table here as well. Okay, so we are imagining it, we already create a database for this. So which means we have the customer table, we have the sale table, we have sale item table, we have product table, right? Right? If I delete, for example, say customer table first, what's gonna happen to the code's logic? It's showing us error. Why? Because if I delete this table, I have something here that's referring to nothing. So that's an error. If I delete sale table, what's gonna happen? Yes,
They're,
this is sale ID.
yeah, the sale of you won't.
Exactly. So sale ID is gonna refer to something as not exist, right? But if I delete sale table first, sorry, what is the table? Sale item. It's not dependent to any. So it's not gonna happen anything. So I would delete sale item first. Then I would go to the sale table first. And then I would go to the customer table. So technically you have to find the parent table in the database. How you can find it? Through the different foreign keys in this row. So because table, let's read it together. Because table references other table with foreign keys, and those foreign keys cannot be null, sometimes we must drop multiple tables. The order in which drop tables is also important. For example, we cannot drop customer table if there are customer records that are referenced to the sale table. Also, we cannot drive sale table, the one that we have here, if there are sale item referring to the sale table. So we always start with the lowest level, dropping sale item first, then sale, then customer. So the lowest level, which means the one that is more like a child in this one, is more dependent to the other. We are not going to remove the parent, then the child. We're going to do it reverse. Okay. So that's why here we start with the sale item, then sale, then customer table. Okay. Customer table here is the most independent table between these three, right? You got the logic? Yeah? Yes? It is important. Always you need to check which one refer to which table. If you are deleting the parent table first, you are doing mistake. So the second one, we are just continue creating. Oh, let's go to the coding for this one. So we are creating table. What is the table name? Be with me. What is the table name? Attributes, customer ID, first and last name, blah, blah, blah. Customer ID is integer. I want it as a not null. For sure, not null, because the primary key. First name, last name, street address, city, state character 2, because we always need just 2 alphabets for the state name. Postal code, country, phone, and the primary key is customer ID. We mentioned that we could have primary key here as well, just primary key. Okay. The second one, we are going to create a sale table. We created the customer table, so we are not going to put the drop table if exists customer. The sale table, again, sale ID, sale date, tax, numeric 8.2. What does it mean by numeric 8.2? What does it mean by numeric 8.2? 8 characters, 8 numbers, 2, and 2 decimal points. And shipping is the same. Primary key is sale ID. Now, see here, foreign key in the sale table. What is the foreign key in the sale table? Customer ID. That's the way that you need to write it. Customer ID references customer table through the customer ID on delete set null. Here it just shows on delete set null. Okay. Let's delete it, run this one. Now we also created another one. And just one technical question. On which credential right now we are working in this app? The student version. We are just creating on our version. We are not messing up with the Red Cat data choose something like that. Because if I go and click on this one, no, my bad. Oh, open in the advanced editor, you will see this is my account. I'm not gonna work on these two because we know if you go and delete the customer, it's gonna delete it forever. So if you want to practice when you go home, always work on the student account and put it as a MySQL. So, and we created the sale table, and again, based on the MySQL Access Oracle, we have some different format for it, but as we mentioned, we are just working with the MySQL. So the data types for MySQL is you can just go there and review it later. We are always go with the MySQL, the primary key, we mentioned how we can address it. And the auto number key, we mentioned that those auto increments the function that we have. So for example, here, what's gonna happen with this code? Alter customer table, we are adding auto increment, which is start from 1000. So technically primary key start from 1000, 1001, 1002, and so on. Then the foreign key, the difference between the different set of foreign key, all the explanation are here. Again, if you need to know more, read this. We just explained all of them, set no, history, cascade, set default, all the detailed explanation here. And now let's create something similar to the red cats that we had, but again in the student account. So if I can go to this one, you can see this is my student account. So technically, it's just telling us first delete whatever you might have practiced before. So delete whatever you have. So you are gonna receive multiple error because probably you haven't had you didn't have the item size table. Here it says drop table. So if I run it, I'm gonna receive less error than you probably because I already created some of them. But yours, you're gonna have more error. If I run it again, I'm just gonna have full error, right? But if it was drop table, if exist, I wouldn't have any error. Okay. So I deleted everything. Let's create table by table. Again, we are just reviewing. This is the customer table. It's adding it. And there is no drop because we just dropped everything. Okay. So the customer table, make sure to create it on your side. And also read the code to understand it. Play with the code to understand. Sale table, again, how these references. Manufacturer table, let me at the same time create it as well. Run. I created the table. run, I created the table. This one, manufacturer table, I just created. Product table, we have the foreign key. Just see the foreign key, how the foreign key just got addressed. Then item size table, just one. Item size, numeric 3.1, primary key is item size. Then create table, employee table, how the employee table, you see, employee table has the recursive relationship. Remember that? Employee table report to employee table. So for that one, they added the new one. They named it manager ID. Last Monday, we mentioned supervisor ID, the manager ID. So right now, foreign key technically is manager ID, which references the employee table, which itself, the employee table itself, and the employee ID on delete cascade, for example. Run it. Fail to open reference table, and maybe I missed something before. Uh, Probably I don't know where I missed something, but yeah, just keep continuing this one. So the reference to the employee failed to open the reference to the employee. We didn't have the employee table. Did you have it? Oh my God, here you see, I didn't create the original employee table. No, no, now it's fixed. It's fixed. And the salary employee and the purchase table and the inventory item, make sure to go through all of them and try to read them. Nothing new. We already been through all of them. I'm just running all of them. And the purchase item at the end. So you see, we just created a database with all of these data. The next step is inserting data to this table. So we had that insert into function on the table on the chapter 2. Okay, so and all the one I just created, I can just drop all of them. Now I have none of them. Okay, so let's go to the first advanced co-editor, MySQL on my students, and let's go to this example. This is the university and course example. The reason I'm always saying you, by learning this course, you have a tool is this one. Just imaginary. You got hired in this school, and now they are giving you this table. Some other people created this table. Now it's your turn to just create a database for them. You have the full knowledge right now to create a database without any doubt. Okay? So, student table, the primary key for this one is already here, a student ID. If it wasn't here, we know that we have to create some primary key for it. Enrollment table, it's referred to two other tables. So section ID, student ID. Student ID refer to the student table, and section ID refer to the course section. Between these two, if you want to start deleting, which one you would delete first? If I delete a student first, I'm not gonna hurt anything. But the point is, If I delete a student, here I have something that I am referring to nothing. You see, if I delete this table, I'm not gonna have student ID anymore. So technically, in this table, we are offering to something is not existed. Okay, so between these two, I am always removing the child table, not the parent table first. Same for the course section. Between these two, again, I would delete this one. But the point is, we have the course table as well. So between the course section and the course table, which one you delete first? Course section and course table, which one? If you delete course, what's gonna happen to this table? Course guide is gonna be referring to something is not existent. So again, we are deleting that one. And the same for the professor. So let's create this table just together. Yes. We are now creating a real database. Where is it? Okay. We are creating table. The table name is student. The attribute is a student ID integer primary key. You see, I just put the primary key here. I didn't add it at the end. We said that there's two ways for creating database. Two table with the primary key. Student name, variable character, student major, character for BCIS, I don't know, BBA, whatever. We know just 4 characters is the maximum, for example, for us. Student phone number and close it. But the point is, we know that we should first drop table if exists and table name is student, right? Comma, comma. If exists, what happened? Where we are. Student. We are the table already exists. Drop table if exists. That's the right code for it. Drop table student. Funky concern. Oh, for my side, you know what? Because I created a lot of tables before, I am getting this error because I created some other table that refers to this one. That's from my side. Your side, you shouldn't have any error for it. So, you have error? What is error?
So you put drop table before the create table thing? Says here. Table student.
Mm-hmm. So I have the table. So let me go through it. What about the others?
I don't know.
You could create The first one, the student table, and you put the drop table if exists.
Yeah.
You didn't put it there. For me, it doesn't because it says that this one is related to the enrollment table. Again, because on my side, I created something, but let me change this one to the other section I had. Probably it should be okay. Just for student privacy, I have to just give me a second. Okay, so right now, let me close this one. I think for this one, we should be okay. Let me. Oh, that's Oracle. So again, for that one, because for that database, I had some other tables that was it gives me error. But let's go one by one. So again, the function for creating table of students is this one. For the course table, we have the course table, course ID, integer, primary key, course number, blah, blah, and also the professor table and also the section table. So for section table, I made it intentionally on your side. If you copy that code, it doesn't work. What is the error with that code? No, no. You tell me what is the error. What do you think is error? The one on your side doesn't have this foreign key here. It says foreign key, course ID, references, course on delete cascade, right? Yes. But we know that again from the book, that's and also the PowerPoint. So we know that we have to address this one as well. So course table, which is through the course ID. So you need to create it. You need to, fix it. I just, on your side, when you're copying this one, just make sure to add this section as well. For yours right now, it's look like this. Let me, for yours is look like this. Correct? This is wrong. Just wanted you to see if you can get the point. Foreign key, course ID, references, this one. But as you see, for my version, I have the right one. For yours, there's a difference. The things that matter here is the way that we need to remove it. Drop table, if exists, so we start removing from this one. We start removing from the enrollment table. Enrollment table is the kinds of one of the lowest level. If I delete enrollment table, what's gonna happen? You tell me. Nothing, because no table refer to this table. You see, if I delete this one, I have a section ID here, I have a student ID here. So no one is gonna be, everything is okay if we delete this one. Then we between this course section is the one that we are gonna delete it. If we delete course section, because right now we deleted enrollment first, this one is gonna be okay because the only thing is here, section ID, professor. If I delete it, nothing gonna happen to this table. And then out of these two, we can have course and professor Doesn't matter which one first. And the final one is the students. Okay, so that's the order. Drop table if exist, enrollment table, drop table if exists, selection table, section table, professor, course, and all of this. So if I just run it, I'm not gonna have any error. So the first error I got again, because in that specific section, this is for last fall section. It doesn't matter. But the point is, in the current section, I changed something on my side. That's why it doesn't let me to delete it, because there was some other table that was dependent to this table. But for yours, which is probably more uh, empty version and more clear version, you shouldn't have any error. I think the function for it was show table, show tables. So if I click on show tables, it shows all of the current table in your student version. So if you want to have a very clear database, you can just go there and delete all of them by one. Click on show tables. I mean, write show tables and run the query. You see, whatever we just created is here. Professor table, section table, student table, all the things are here. I don't know how many table you have on your side, but that's the way. Show tables. That's it. That's a function for it. Okay. It doesn't work. Make sure to put it on MySQL. Just show tables. You see this happens. You see it for me is more than it. If you want to have like a more clear database, I mean clean database, you can just go there and delete all of them and then try to play with it. You can create as much as you want. So for this one, this is a game for you in home if you are interested. Just these two. Start playing with it on home and start creating. Okay? No. All the credit goes to yours when you learn. So let me stop the recording.